Download this code from codegive.com, link in the description below. Chat 14B time series with LLM from ByteDance, local installation and tutorial. This tutorial provides a comprehensive guide on how to install and use the Chat 14B model for time series analysis, leveraging its LLM capabilities, directly on your local machine. We'll cover everything from setting up the environment, downloading the model, configuring the necessary dependencies, and finally, running example code to demonstrate its usage. Introduction to Chat 14B and Time Series LLMs. Chat 14B is a large language model, LLM, developed by ByteDance, the creators of TikTok, and is particularly well suited for time series analysis due to its understanding of natural language and ability to reason about patterns and trends. This opens up opportunities for forecasting, predicting future values in a time series based on historical data and contextual information. Anomaly detection, identifying unusual or unexpected patterns within a time series. Time series classification, categorizing a time series based on its overall characteristics. Question answering about time series, answering questions about the time series data in natural language, like what was the highest sales volume in 2023, or identify periods of significant growth in the last quarter. Time series data generation, creating synthetic time series data that mimics the characteristics of real-world data. The key advantage of using an LLM like Chat 14B for time series is its capacity to incorporate external knowledge, handle missing data more gracefully, and offer explanations for its predictions in a human-understandable format. Traditional time series models like Arima or Profit are primarily focused on statistical patterns, whereas LLMs can leverage semantic understanding. 2. Prerequisites. Before we begin, ensure you have the following. 1. Hardware requirements ***GPU ***. A powerful GPU with at least 24 GB of VRAM is highly recommended. The Chat 14B model is quite large, and running it on a CPU would be prohibitively slow. NVIDIA GPUs are generally favored due to better PyTorch support. Consider an NVIDIA RTX 3090, RTX 4080, RTX 4090, or equivalent. You might be able to run it on a slightly smaller GPU with appropriate quantization, explained later, but performance will degrade. *RAM at least 32 GB of system RAM. More is better, especially if you're working with large data sets. Storage enough storage space to download the model weights, which can be several dozen gigabytes, and your data set. An SSD is preferred for faster loading. 2. Software requirements Python 3.8 or higher is required. CUDA toolkit install the appropriate CUDA toolkit version compatible with your GPU. The exact version depends on your PyTorch version. Check the PyTorch website for compatibility information. *CUDNN install CUDNN, NVIDIA CUDA Deep Neural Network Library. This library accelerates deep learning computations on NVIDIA GPUs. *Git is necessary for cloning repositories. *pip Python package installer. 3. Setting up the environment. 1. Create a virtual environment, recommended. It's best practice to create a virtual environment to isolate your project dependencies. This prevents conflicts with other Python projects. 2. Install PyTorch *. Install PyTorch with CUDA support based on your CUDA version. Visit the PyTorch website, https://pytorch.org/getstarted/locally/ https://pytorch.org/get-started/locally, for the specific command based on your system configuration. For example, if you have CUDA 11.8, you might use verify PyTorch installation *. 3. Install transformers and other dependencies *. Transformers *. The Hugging Face Transformers library is essential for loading and using pre-trained LLMs. Accelerate * used for distributed training and inference, but also provides useful utilities for memory management. Sentence piece *. A tokenizer often used with LLMs. anops * for tensor manipulation. Formers * an optional but highly recommended library for memory-efficient attention mechanisms. It can significantly speed up inference and reduce memory usage. Check its installation instructions, it may require specific CUDA versions or compilation steps. Refer to the Xformers repo for guidance. Scikit-learn * for time series data pre-processing and evaluation. Pandas * for data manipulation and analysis. Matplotlib * for data visualization. 4. Downloading and loading the Chat 14b model. Unfortunately, ByteDance doesn't publicly provide a direct downloadable link to the Chat 14b model. Access is usually granted via a limited access agreement or cloud platform offering. So, let's proceed under the hypothetical where you have downloaded the necessary weights. Please ensure you have the legal right to access and use the model before proceeding. Assume you have the model files, pytorch_model.bin, config.json, tokenizer_config.json, etc., in a directory called chat14b. Replace this placeholder with the actual path to your model directory. Explanation **** auto tokenizer.from_pretrained, model_path, loads the tokenizer associated with the model. The tokenizer converts text into numerical tokens that the model understands. Auto model for causal lm.from_pretrained, loads the pre-trained language model. Auto model for causal LM is a class specifically designed for causal language models, models that predict the next token in a sequence. Torch_type equals torch.float16, this option reduces the memory footprint of the model by using half-precision floating point numbers, float16. This can significantly improve performance on GPUs with limited memory. Important ** ensure your GPU supports float16 computations. If not, remove this argument, and the model will default to float32, which uses more memory. You might also try torch.float16 if your GPU supports it and it offers better numerical stability for some models. *device_map equals auto, this is crucial for running the model on multiple GPUs, if you have them, or for offloading parts of the model to the CPU if you don't have enough GPU memory. The device_map equals auto option automatically distributes the model layers across available devices to maximize performance. *trust_remote_code equals true, if the model requires custom code, you may need to add trust_remote_code equals true. Use this cautiously, as it executes code from the model repository, which could pose a security risk. Only use this if you trust the source of the model. This is less common for models directly downloaded from trusted sources like Hugging Face Hub, but may be necessary for private or less common models. Quantization, optional, but highly recommended. If you have limited GPU memory, quantization is essential. Quantization reduces the precision of the model's weights, reducing memory usage at the cost of potentially slightly reduced accuracy. A 4-bit quantization, using bits and bytes. The bits and bytes library provides easy-to-use 4-bit quantization. Install it. Modify the model loading code. Explanation asterisk. Asterisk bits and bytes config. This class configures the quantization process. Asterisk load underscore in underscore 4-bit equals true, enables 4-bit quantization. Asterisk bnb underscore 4-bit underscore quant underscore type equals nf4, specifies the quantization type. nf4 is a recommended choice for its balance of accuracy and memory efficiency. Asterisk bnb underscore 4-bit underscore use underscore double underscore quant equals true, enables double quantization, which further reduces memory usage. Asterisk bnb underscore 4-bit underscore compute underscore type equals torch.float16, specifies the data type for computations within the quantized model. Setting this to torch.float16, if your GPU supports it, can significantly improve speed, as the computations are performed with half-precision floating point numbers. B8-bit quantization, using bits and bytes. Similar to 4-bit, but with slightly higher precision and less memory reduction. Choosing quantization asterisk. Asterisk 4-bit quantization offers the greatest memory savings but might lead to a slight reduction in accuracy. It's ideal when you have very limited GPU memory. Asterisk 8-bit quantization provides a good balance between memory savings and accuracy. It's a good choice if you have some GPU memory but still need to reduce the model's footprint. Asterisk no quantization, float16/float32, offers the best accuracy but requires the most GPU memory. Use this if you have enough GPU memory. 6. Preparing time series data. Let's create a synthetic time series dataset for demonstration. This code generates a simple sine wave with added noise and splits it into training and testing sets. You would replace this with your own time series data. 7. Time series analysis with chat14b. Here's how you can use chat14b for time series tasks, focusing on forecasting. Explanation asterisk. 1. Generate underscore forecast underscore prompt asterisk. This function creates a prompt that instructs the LLM to perform time series forecasting. The prompt includes the historical data, the specific question, and the desired forecast horizon. A good prompt is crucial for getting good results. Experiment with different prompt formats and wording. Consider adding information about seasonality or other relevant factors. 2. Predict underscore time underscore series asterisk. This function takes the prompt and feeds it to the LLM to generate the prediction. It handles tokenization and generation. The generate method takes several parameters to control the generation process, including max underscore length, number underscore return underscore sequences, do underscore sample, top underscore p, top underscore k, and temperature. Tuning these parameters can significantly affect the quality and diversity of the generated output. These params influence how creative the response will be. 3. Parse underscore predictions asterisk. LLM's output text. You need to parse this text to extract the numerical predictions. This example assumes a simple date, value format. This is the most fragile part and will likely need adaptation based on the LLM's output format. 4. Plotting and evaluation asterisk. The code plots the training data, the actual test data, and the predicted data. It also calculates the root mean squared error, RMSE, to evaluate the accuracy of the forecast. Important, proper date alignment between the actual and predicted data is crucial for calculating accurate evaluation metrics. Important considerations and improvements asterisk. Asterisk prompt engineering asterisk. The quality of the prompt is crucial. Experiment with different prompt designs to improve the accuracy of your forecasts. Consider including information about Asterisk seasonality asterisk the data exhibits strong annual seasonality. Asterisk trends asterisk there is an upward trend in the data. Asterisk external factors asterisk sales are affected by weather conditions. Asterisk specific events asterisk there was a major marketing campaign in July 2023. Asterisk data pre-processing asterisk consider standardizing or normalizing your time series data before feeding it to the LLM. This can improve performance. Asterisk fine-tuning asterisk for optimal results, fine-tune the Chat14B model on your specific time series dataset. This will allow the model to learn the specific patterns and characteristics of your data. Fine-tuning requires more data and computational resources but can significantly improve accuracy. Look into LoRa, low-rank adaptation, for parameter-efficient fine-tuning. Asterisk ensemble methods asterisk combine the LLM's predictions with those from traditional time series models, arima, profit, to create an ensemble model that leverages the strengths of both approaches. Asterisk error handling asterisk implement robust error handling to deal with potential issues such as invalid data or unexpected LLM outputs. Asterisk context window asterisk LLMs have a limited context window, the amount of text they can process at once. If your time series is very long, you might need to break it down into smaller chunks or use techniques like summarization to reduce the input length. Asterisk interpretability asterisk use the LLM to explain its predictions. Ask it to provide reasons for its forecasts. This can help you understand the model's reasoning and build trust in its predictions. Asterisk dealing with missing data asterisk LLMs are often better at handling missing data than traditional time series models. You can include the missing data in the prompt with a placeholder value, example nan, and ask the LLM to impute the missing values. 8. Advanced techniques. Asterisk LoRa, low-rank adaptation, for fine-tuning asterisk LoRa is a parameter-efficient fine-tuning technique that allows you to adapt pre-trained LLMs to specific tasks with a small number of trainable parameters. This is a great way to fine-tune Chat14B on your time series data without requiring a massive amount of GPU memory. The PEFT library from Hugging Face provides an easy way to implement LoRa. Asterisk time series decomposition asterisk decompose the time series into its trend, seasonal, and residual components before feeding it to the LLM. This can help the LLM to better understand the underlying patterns in the data. Asterisk external knowledge integration asterisk incorporate external knowledge into the prompt to improve the LLM's performance. For example, if you're forecasting sales, you could include information about economic indicators, competitor activities, or marketing campaigns. Asterisk chain of thought prompting asterisk use chain of thought prompting to encourage the LLM to reason step by step before generating its prediction. This can improve the quality and explainability of the predictions. For example, you could ask the LLM to first identify the trend in the data, then identify any seasonal patterns, and finally generate the forecast based on these factors. 9. Troubleshooting. Asterisk out of memory errors, boom. Asterisk reduce the batch size. Asterisk use a smaller model. Asterisk enable gradient accumulation. Asterisk use mixed precision training, float 16 or float 16. Asterisk offload some of the model to the CPU. Asterisk use quantization. Asterisk ensure you are closing unused resources such as figures. Asterisk slow training / inference asterisk. Asterisk use a faster GPU. Asterisk optimize your data loading pipeline. Asterisk use mixed precision training, float 16 or float 16. Asterisk enable XLA compilation, if supported. Asterisk unexpected results asterisk. Asterisk check your data for errors. Asterisk experiment with different hyperparameters. Asterisk try different prompt designs. Asterisk ensure you have set the seed for random number generation to ensure reproducibility. Asterisk installation issues. Asterisk carefully follow the installation instructions. Asterisk check the versions of your libraries. Asterisk consult the documentation for the libraries you're using. Conclusion. Using Chat 14b for time series analysis is a promising approach, offering the potential to leverage the power of LLMs for tasks like forecasting, anomaly detection, and question answering. However, it also presents challenges such as high computational requirements and the need for careful prompt engineering. This tutorial provides a solid foundation for exploring this exciting field. Remember to experiment with different techniques, fine-tune the model on your data, and continuously evaluate the results to achieve optimal performance. Good luck! Remember to consult the model documentation and community resources for further guidance and support.